Hi, everyone. My name is Darek. I'm a machine learning engineer at Weights and Biases. Super excited about this session. I'm calling in from Warsaw. If you are already in the chat in the event, please write a message, say where you're calling from, how did you find out about the session. It's gonna help me to also understand what kind of audience we have and customize this delivery for the audience. The reason I'm super excited about this session is it actually includes several topics I'm very passionate about. First one is solving machine learning problems. And today we will be working on PII data detection, very relevant topic these days. The second thing that I'm excited about is Kaggle. This use case is coming from a Kaggle competition. Kaggle is a machine learning competitions and platform and a community platform, and we will take a look at this machine learning problem in the context of a Kaggle competition. And the third thing I'm passionate about is obviously Weights and Biases. I work at Weights and Biases. I think this is a great tool for machine learning practitioners that is going to help us approach this problem and come up with ultimately a competitive solution. Now, this is going to be very much a working session. I think I spent quite a bit of time preparing for it, but I still think we're still at least I'm still in the process of making sure I have the right pipeline to do well in this competition and to get a good score. And I'd love to share with you actually through a live session how I'm approaching this. And ideally, if there are questions and discussion, then we can take it in the direction that is relevant for you. Okay, let me double check. Please write a message in the chat if you are in the event. It's gonna help me make sure we have I can answer any questions and respond to feedback. All right. So how are we progressing today? I will share this general approach, and we'll start talking about some points in this approach. Whenever I start working on a new machine learning problem, and this might be in the context of a Kaggle competition, but this may also be in other contexts, I usually like to start with a simple baseline. Then I try to spend quite a bit of time really understanding the data. An important aspect before you actually spend a lot of time on modeling is to decide on a cross-validation or a validation approach. And we'll chat today about how we might approach it for this specific problem. Then it makes sense to actually spend some time and instrument the machine learning pipeline. And specifically today, we will talk about experiment tracking, dataset versioning, and doing error analysis with weights and biases. And once we have this set up and established and instrumented, we can then actually iteratively improve our pipeline, get better and better score, and spending this effort up front on having a good CV, on having a properly instrumented pipeline will make us way more productive as we're kind of working on this problem. Now, I'm getting a comment that we might not be able to see your messages. So apparently the chat might not be working, but our team member is looking potentially into a solution. So we'll see if we can potentially jump and move questions over to Discord. We'll share with you an approach to ask questions throughout this session. But in the meantime, I'll kind of continue, and hopefully this is gonna be relevant. So the first thing I want to do is talk a little bit more about this problem that we are solving, or this machine learning competition, especially if you're not coming from Kaggle and you want to understand really what we're talking about. So let's take a look at this Kaggle competition. It's coming from Learning Agency Lab, which is an organization that is, I believe, a nonprofit that develops solution for the education sector. And they came up with this problem, which is specifically about developing automated techniques to detect and remove PII, personally identifiable information, from educational data. And especially now in the era of large language models, we're working a lot with text, with NLP data. And one obvious problem with a lot of text is it often contains PII, and PII is something that is protected, often legally, and it's very important for businesses, for organizations to follow the rules, to follow the law. And very often that means you might need to redact or remove PII from your data. So it's a very relevant problem also for the industry, also outside of educational data. In fact, before in my previous experience in the industry, I was also working on PII detection because of how important it is to tackle this properly. So this is the competition, and I think one thing that is very important, usually with Kaggle competitions, is the metric and how your solution is going to be evaluated. We are typically on Kaggle provided with a data set, and usually that data set contains there is a training data set, and then we need to score our model on test set. And test set in this case is hidden from us. The submissions are evaluated on micro F beta score, which essentially is like F1 score, but it weighs recall 5 times more heavily than precision. And that also makes sense in the context of this problem, because we want to make sure we do not miss any PII. So, and sometimes it's better to have false positives than false negatives. So recall is gonna be very important. And it's good to also think about both recall and precision as we are approaching this problem. We have different classes of PII that we need to detect in our text, and we need to submit the result of our model, which is essentially the list of tokens and the classes that these tokens represent. Okay, now what we want to ultimately do well is we want to do well on this leaderboard. Now, Kaggle, I think, is very professional because there are two types of leaderboards. The first one is public. This is where we can see our score being evaluated as we progress throughout the competition. And you can see the current best score is 0.972, which is already pretty high. But at the end of the day, at the end of this competition, we will be evaluated on a holdout test set, and the scores may differ. And this private leaderboard will only be visible after the competition. And because we are evaluated on this hidden test set, it's very important to do proper cross-validation, and to be able to predict which of our solutions are robust enough and can do well on this hidden test set that we don't know much about. Okay, so this is the Kaggle competition, and we'll learn more about this as we look at the data. I think it's always good to understand the problem by looking at the data. But before we get there, I want to also tell you a little bit about weights and biases, which you might potentially know about. But yeah, weights and biases is a platform for machine learning practitioners, for AI developers, which covers the broad life cycle of MLOps, starting with machine learning experiments, with versioning data sets. It goes through visualization and understanding the data, optimizing training with sweeps. Then it also has components like model registry and automations, which help you organize your models and machine learning pipelines in production as you kind of getting into production. And it also contains some LLM tools such as tracers, and definitely there's a lot of capabilities here, way more that we can actually touch in this session. I will specifically call out artifacts, tables, and experiments, because this is going to be the focus of the session today. This is something that I'm personally using right now to approach this competition, and I will show you how to use it if you choose to do so. Okay. Now, the first thing I'd like to chat about is is how to do this validation properly. So you've seen already public leaderboard, and ultimately you want to do well on the public leaderboard. But on Kaggle, like you can only evaluate 5 experiments on the public leaderboard. And you also want to be careful with the public leaderboard, because if you do a lot of submissions, if you do a lot of experiments that are evaluated on this public leaderboard, you may be overfitting to that to that um, to that data set. But like that doesn't matter, because ultimately you be evaluated on the private test set. So for that reason, it's very important to also do like cross validation or local validation. Um, and one way of checking if your cross validation approach is good is to see the correlation with leaderboard. So I have just like really started submitting the results of my experiments yesterday. So I don't have much to show here, but I did submit these 4 experiments that I evaluated on my local validation, and you can see there's pretty good correlation. Like it's not ideal. Like in this case, that experiment was worse on CV but better on the public leaderboard. But I think it's like you can probably see like there's a pretty good correlation. So I'm gonna share with you like how I'm approaching CV right now. It may not be the best approach, but I think it's something that we can potentially discuss. So if we look at the data, specifically the train data set, let's take a look at train. Let's check how long it is. So there's 6,807 essays, student essays in train dataset that are annotated for personally identifiable information. But just knowing the number of essays is not enough. Like we're actually interested in the labels and the different classes of labels. So what I've done here is I actually checked like for all of the unique labels, and I counted the number of essays that contain this specific label. So if you look at the actual distribution of labels across this, close to 7,000 student essays, there are a lot of essays which do not contain any labels because they do not contain PII, which I think is a realistic scenario. Like this is a real data set of essays, I think, written by participants of a massive online course. So and this is like a real distribution. Like a lot of essays do not contain PII. But then there are quite a few that contain especially names of students, and you can see there's around close to 900 student names in this, or essays containing student names in this data set. But there are also some classes that are very rare. There are just 4 essays with a phone number, and there are only 2 essays with a street address. So that is something that we need to be very cautious about. Now, fortunately, the metric here is micrometric, which means like the more popular classes will be also like more relevant, will have bigger impact on the metric. But I still think like especially if we want to do really well in this competition, we need to be careful and we need to be properly predicting most of these classes. So one thing I would like to do at this point, well, actually, like, let me share with you like how I'm approaching CV just based on these numbers. So my approach is I want to make sure I have all of the rare classes in my validation, and that's that choice has some pros and cons. So the positive side is I'm using like all of the competition data that is very rare, that is very valuable for these labels for my validation. And I can really understand how my models are performing there, at least as much as I can from 2 examples, but I think it's better than nothing. The downside is if I'm training with this approach, I do not have any competition labels in my training set. So if I just use the training set, I will have no chance of predicting street address or phone number, because if I move all of those essays into my validation, like they will not be represented in the train set. Now, what I think is going to happen in this competition is that there's already quite a few synthetic data sets that are being shared. So I will put what I'm going to do is put the synthetic data sets in my train, which will contain these rare labels, but I'm going to hold out all of these rare labels for validation. And again, that's a choice that can be debated, but I think I will go for it right now. So I will take all of the phone numbers, essays with phone numbers, all of the essays with street address, put in my validation, same for usernames. And then for the classes that have more examples, like I'm going to split the emails and the ID numbers and like take 100 of the student names or essays with student names, put that in my validation, and also like take 1,000 essays without PII. And that's an opinionated choice. Like there's no real science behind it, but I think the science will come by looking at this graph, right? So as long as I can keep this correlation between my CV and the leaderboard, then that means that the CV should be, that the local validation should be robust. So that is the approach. And then like I said, I think now is a good time to really look at the data. A good library to visualize data that is annotated for PII for token classification is Displacy from the Spacey team. And as you can see, like Kaggle is very good because you can learn a lot from others that share their code and their approaches. So in this case, I'm benefiting from this specific notebook that already implemented a way to visualize these essays with Displacy. But the additional thing I'm going to do is actually, let me skip this truncation. I think we may maybe talk about it later. Is I'm going to load this up I'm gonna load the visualizations along with the data into a weights and biases table. And what is a weights and biases table? I think the best way to show it is to actually take a look at it. So this is the view of this original data set, like all of the training data, with this additional like post processing. So I'm marking here like whether a specific essay, like this is an example of an essay. You can see assignment mind mapping. There's like a challenge. There's a selection. This is like the text of the essay, and I'm then checking like if there are any classes of PII in this essay. In this case, there is none. So the column other is has a positive label. And this is not in my validation split. It's in the train set. And I also have this visualization. Actually, one thing I would like to do is maybe just focus on some columns. I think like looking at all of this data may not be very productive, but so let's take a look at the document number. Let's, I think the full text may be, yeah, the full text may be relevant. So let's add it as well here to the displayed columns. And I think, yeah, maybe let's add other now as well, and let's add our visualization. So this is what we saved with Spacey. Now, if I just move this around a little bit, you can see the full text. You can see this this other column, and you can see the visualization. And maybe let me just sort this so that we start by looking at all of the essays that contain some PII. So let's take a look at one of those. And let's see if there's any PII here. And am I looking at the right column? I think something might be off here. Let me actually do something else. As you can see, this is really a working session. So let me see the reverse. No. Okay. Okay. So for some reason, I might have. Yeah. Okay. I understand what I did now. So actually, like if other contains one, then that means like there is no PII in the essay. So we actually want to look at those that are tagged as 0 here. So let's take a look at this essay. It contains a student name, Paola Garcia, and you can see like there is like the annotations follow the bio scheme. The B stands for like beginning of the class. I stands for, I don't know, like maybe intermediate, but it's the continuation of the class. And there's like also O, which is other, which is all the tokens that are not highlighted here. Let's see if there's any other PII. In this case, it's just the student name, Paola Garcia. And you can see this is at the top of the document, so maybe the location will be important. What I can see also from here is like it follows like a typical approach where you have the capital letters starting both the first name and the second name. So maybe that gives us some indication, already some indication how to think about student names. Let's take a look at some other examples. Maybe taking a look at this essay. Again, Tony Flores, which is the student name. Tony Flores, the same name appears again here. I think that is something that may be important. If we already identify one name and it repeats in the essay, then we should be able to classify it again. Or maybe if it appears twice, then that's a better signal to pick up this name. So that's something that may be another helpful information. And you can see like this is a pretty long essay from Coursera with a specific date, and the course is Design Thinking for Innovation. Now, we are looking at the student names because this is the most popular class. But actually, maybe let's take a look at some of these other classes. So maybe I can put a filter here, and let's say we want to take a look at the ID numbers. And so I will just save. I will just put in this filter and apply it. And now, now we can see ID numbers. And we can see like there is this specific number here, which is annotated as ID. Now, not being a professional annotator, I'm not sure if I would pick it up and conclude this as an ID number. Maybe there's actually like a rubric for annotators that is shared by the competition host, so that might be something I may want to look at and really think about like how to think about these ID numbers. I can also depend on the model to figure it out, but in this case, I think IDs is one of the rare classes, so I may not have enough examples for the model to figure it out. So this is maybe where I need to spend a bit more effort looking at the annotation guidelines. Let's look at the final one here, and just to see this. I think this one, this one is maybe something I would personally be able to pick up because it says like there's an interviewer pin, and this looks like an ID number. There's also like the name here of the student, and let's see if there's anything else. Yeah. So what we can see here is like the only thing we've done so far is we visualized our essays by highlighting the classes that we need to recognize. And we're already getting pretty good insights. And we can use these capabilities of tables to do this filtering, to do this sorting. We can also do group by. But I think I'm gonna skip like stop here and get into training. Actually, one thing I wanted to do is start a training run. I missed to do that at the beginning of the session, but maybe there's still time to train a model. So, like I said, I've just started like really training good models last night with this pipeline. So, as you can see, like I have this training script, and we can take a look at this in a moment, and I can pass some arguments to that training script. The last experiment that I've done is my best experiment so far. And as you can see, it has like, it's the Berta v3 base model that has external data generously shared by Nicholas Broad. And it's trained for 3 epochs with learning rate 1E neg 5. So maybe what we can do is actually prepare this already. Maybe we can train another experiment and now just bump up the learning rate, but keeping all of the other things constant. So let's start this experiment and let's just see what's happening. So you can see there's a bunch of configs that I'm passing here, and it's starting a weights and biases run to track this experiment. So we're gonna come back and look at this run in a moment. But just to make sure like we're progressing, I'm checking if we have any feedback from the host around the messages. So yeah, we may need to go without conversation, but if we are not able to chat throughout this session, I'm hoping this video will be recorded and we will share it, and we will have we can have the conversation either on Weights and Biases Discord, or we can actually have the conversation on Kaggle forum. So I'm gonna show you where this conversation might happen. Yeah, there's gonna be a Discord channel, but I think this Kaggle is gonna be helpful potentially as well. As you can see here, I actually made a comment about this live training session on the Kaggle forum, and I'm just gonna write that we are live. Please feel free to ask questions here. Okay, so yeah, so you can ask questions on Kaggle. We're gonna put up a message and also have like a Discord server for you to join. Going back to the slides, yeah, you can see the 1db.me/PII event chat, and this is where you can join to ask questions live throughout the session. So I want to make a detour and talk a little bit, just a tiny bit, on this scroll prize, which is a really big competition that is organized by Nat Friedman, and the goal here is to read ancient scrolls that have been burned like thousands of years ago. It's a super difficult problem, and the host like decided to create like a really compelling prize. I think the original 100K is already is already like a continuation. Like there's like they've awarded already over $1 million in prizes, and actually like they solved it, like which is super super compelling. And there's been this article about the person that I think won this competition, and they made a comment that they started writing the code, but soon concluded they might have better luck if they just stared at the images for a really long time, and that led to an insight that ultimately led to the winning solution that gave this person like the top prize in this challenge. So and that's something that is also consistent with my experience. I think spending a lot of time looking at the data and also looking at the model predictions can be very, very helpful and can give you insights to ultimately come up with a very compelling solution. Now, looking at the data is one thing, and we already looked at our training data, which I think is very relevant, can be very helpful to think about how to solve a problem like this. I think it's important to look at how your models are training, look at all of the metrics. And it's also important to look at the model predictions and see like how they differ from the ground truth, like what are the errors that the model is making. So let's take a stab at that. So I'm going to show you just a couple of things from the code. Now, I am planning to share this code hopefully soon. It's still something that I need to clean up a little bit. It's very much work in progress, but I'm gonna share with you. This is the training script that we just started. By the way, let's take a look at how it's going. I think we are. Yeah, I think we are going like the loss is going down, but actually like this output is not really meaningful. I don't find it super helpful. You can see like it's still the first epoch, But yeah, but there's better way of looking at the loss than than just reading this in the terminal. So let's switch to Weights and Biases workspace. Let me refresh this because we just started a new run. You can see, by the way, this is the experiment that I just finished. Like this is that I finished today. This is my best experiment. It has local validation score of 0.99, close to 0.95. This is the seventh experiment that is also like my best one on the public leaderboard right now. Let's take a look at the recent one. It doesn't have like the final F5 score on the validation because it's still running, but maybe we can already see some stuff, and you can see we can start seeing some training metrics. And this is the loss. The loss is cut here because I edited this chart. There's if I remove this. If I remove this this filter here, like you can see, like the loss starts very, very high, and then it quickly converges. But I think the really interesting things start happening in this range. So we can again like cut it at maybe 0.05. Maybe later we'll need to like move this even lower. And then like we can see like, okay, this is going down here. Like there are still some bumps. The learning rate is still pretty high, and we can see how this training is progressing. Now, this that's actually one thing we may want to look at is to see how this loss is evolving compared to the previous best experiment. Like if that loss is not competitive, maybe we can kill it and start something new. But yeah, if I go back to the runs here, maybe I just want to take a look at this current and the previous experiment. So let me filter everything else out and just compare these two experiments. And I want to look at the training metrics. You can see like I'm using a Hugging Face trainer, which has a pretty good integration with weights and biases, and I'm also logging a lot of stuff, a lot of metrics, and that means like I have a lot of charts here. So one thing I sometimes like to do is actually maybe what I can do is create a section. Let me add a section here, and I'm going to rename it, and I will call it my training metrics. And I want to specifically look at the training loss because as I'm kind of monitoring the training, this is the one that is very important for me. I can now resize this chart a little bit, and you can see that, whoa, like there's a massive spike here. You can see like it has a higher learning rate than the previous one. We can compare the learning rates. And you can see like the loss goes down faster, but then like right now it has just spiked. And if it doesn't recover, then maybe it will not be as compelling. Maybe I should go the other direction and like make the learning rate lower and go for a longer training potentially. So these are some insights from like looking at the training. Now the training metrics is something that helps me kind of monitor this run as it continues. But what actually matters is the eval metrics. So I also have a bunch. Let me actually pull up some other experiments that I trained. So this one was pretty good, and maybe let me just put up like my initial baseline here, which was I think this one. So so now I'm looking like at a couple of experiments here, and you can see I'm comparing like the final F5 metric, and I'm comparing them at different thresholds. Now, one thing that has been shared also in this competition is a way of like improving the score by adding thresholding for the negative class, because recall is so important. Then that means that if we threshold like some probability level for the negative class, and if it's If it's below that threshold, then we take only the positive classes into consideration. So we're not going to go through the code for that, but the important thing is you can threshold the scores, and that will give you a different outcome, a different metric. And if you can if you look at here, like the bright water, the blue experiment is the best at all of this thresholds. But the best value is actually like with I think 0.6. We can actually take a look at this experiment and like see what were the actually let's take a look at that. I think it's gonna be helpful to see the scores here, and you can see, well, no, I was wrong. So 0.7 was the best threshold in this case with 0.953 local validation score. So I would use this. I actually use this threshold for my inference. Okay, let's go back to the dashboard. You know, I like we're logging all of this evaluation metrics, but actually, like I can show you the code. The code is coming, by the way, as usually on Kaggle. You can get a lot of good insights from the public code section. And in this case, Raja Biswas actually shared the metric calculation code, which also calculates the fine-grained metrics, which means I have the overall score for like the F beta, F5 score. I have the precision and recall like across all of the entities or across all of the classes, which is what is ultimately matters. But I also calculate the precision, recall, and F5 for each of the classes. So if I count like 3 metrics multiplied by 12 classes, I have like 36 metrics that I'm measuring in this experiment, actually like close to 40 now, with if you also add like the overall summary. So this is like a huge number of metrics, and maybe looking at all of them at the same time may not be so important. So again, I'm gonna add a section here, and I will just call it let me rename it, and I will call it my eval metrics. And let's say right now I just want to look at the like the main metric, which is the F5 score across all of the entities. And as you can see, like I'm logging a lot of metrics here. So if I go back, yeah, once I organize this dashboard, it's gonna be more meaningful. And this is ends precision. Once I do this, I will switch into questions because we've just been, yeah, this is the main score. So I will now move this. Okay. I will move this here, and maybe I can also pin like this my evaluation metrics, and I will also pin the train metrics. Let me see, where do I have them? Okay. Okay, train loss. Okay, for some reason I don't see them anyways. Yeah, so this is the F5 metric. Now, let me pause here and check the questions. So the first question is how token classification really works. Does it classify token one by one, or it classifies on full sentence and find out where O is or PII tag? That's a great question that will take us to the next section, which is looking at our model predictions. And when we look at the predictions, I will show you how it actually works. The next question is like, will the code for this be shared? Yes, it will be shared in the next couple of days when I clean this up, and you will be able to find it on Kaggle, and we will also share the link on our Discord. Okay. We can see like we already have the first eval metrics here, and I think it's looking pretty good. Actually, I think I will have now. Yeah, these are my training metrics. So I think I can. Yeah, I was looking at the wrong view. This is what I want to. This is what I want to pin to the top, and I also want to. Yeah, I created this. By the way, one thing which I just got confused myself about is we are having like two views here. One is the view across experiments. This is where I can compare multiple experiments and like look at the charts like across experiments. And then I have this individual experiment section where I look at specific experiment. And this is just looking at this single run. So let me go back to this overall view. Like I would actually want to do now also like the same thing and just look at the F5 metric at this F5 metric across experiments. And now I will just look at it here, and we can see the last one is actually like looking better than the previous one. So that tells me that I should submit it. Let's see what score we get. I will let you know after this session what score we get, and hopefully like this correlation between CV and leader B is gonna hold. So let's take a look at the console and see what's happening here. You see now it's running the code to visualize errors. It also computed the final metrics for the different thresholds. So we have I think now 0.6 looks like the best threshold. No, actually 0.9. You can see like this threshold might be something that could be tricky. Maybe it's better to get rid of that threshold and figure out a different way to predict. So this code is still visualizing the errors. You can see, I think there's like around 135 essays where there are some differences between ground truth and prediction, but we will not wait for it. We'll look at the previous experiment, the previous best. And other than all of these metrics, what I've logged here is I've logged a table with errors. And specifically, like already like filtered the columns here. This is the target. This is the target that is in my ground truth. So you can see this is like a URL, and the class is URL personal. My prediction did not pick this up. And I also have like the visualization of prediction and visualization of ground truth. So let's take a look at the ground truth first. You can see like this is already like a part of the essay. I applied truncation here just to have like the smaller bits of text. And in this case, we see there is like this personal URL, which is annotated. And if I look at my prediction, what I'm doing here is I'm annotating each token by the class that has the highest probability, except for the other class, because that would not be very meaningful. And you can see here that actually this URL is found to be of this class. So I'm printing out the probabilities for these tokens, and it starts with like PURL personal probabilities 0.97, which means like this should be picked up by the model, but there's no prediction here. So what this tells me is actually like the model is doing well. And going back to the question how token classification works, it looks at the entire text. So it has access, like this is going through an encoder. So the encoder has access to the entire sequence, to the entire text. But then it classifies each of the tokens in that text, and it gives it probability for each class. So what I'm coloring here is I'm coloring the top probability for each token with its different colors, and then the transparency of that corresponds to how likely that class is. And as you can see here, like this gray color is for URL, and this was picked up by the model with high probability. So something has gone wrong in my prediction processing that did not pick up the string. Actually, one thing which we could do here, and again, this is a working session. I will share this code, and you will be able to do this yourself, like with your models. But maybe if I just sort this here, and this will give us like all of the actually, yeah, I want to see. Actually, let me sort it this the other direction. Oh, yeah, I'm going to, yeah, maybe let's do it differently. Maybe let's just add a filter. I think sorting is not working for some reason. So I want to filter the row prediction string, and it should be equal to an empty string. And this gives me all the false negatives, right? So in this case, my model did not come up with a prediction, but I have this ground truth annotation. So let's take a look at just one of those. And again, I can see that my model is picking up actually like the student name, MD Carrillo. It's picking up email with these green tokens here. And what else it's picking up? It's picking up the URL. So the model is doing the prediction well, but for some reason, like this prediction string did not get created, which means yeah, I may have missed something here. So I need to look back at my parsing code, and this visualization already gives me some insights on what I may need to improve. So let's do the other thing. Let's now check for the false negatives. So or false positives. Sorry. So our target string is empty, but I'm making a prediction. So in this case, I'm predicting a student name. Let's take a look at the prediction. Okay, and when I presented my drawings to Madelon, I felt a positive energy from scratch. It seems like it's a real name because it says she was surprised to see something. So Madelon is predicted as a student name, but if I look at the ground truth, in the ground truth, it's not annotated. So Madelon is not annotated. So again, I may need to go back. It seems to me like my model made a good choice potentially, but the ground truth is not annotated. So maybe I need to better understand the rubric for annotators and think about like when would they mark something as PII, or maybe there is noise in the labels. That could very well be the case. And if the labels are noisy, that's a bigger problem potentially. Let's take a look maybe at some other one. So again, I'm predicting here like some student names. Let's take a look at my prediction. Challenge Andre Sinde. It's predicted as a student name, and there's Diana Vallejo, which again is like a name. Like both of these seem to be names, but they are not annotated, right? Let's take a look at the ground truth again. Let's take a look at the ground truth. The ground truth is actually, am I looking at the right one? Current situation. No, I was looking at the wrong row. No, this is this. This is the this is my model prediction, and this is the ground truth. And in the ground truth, it's not annotated. So again, I think the challenge here is going to be like figure out which of these names is clearly a name is should be annotated or not. That's something we can get through this error analysis. Okay, let me take a look at the questions. In addition to talking about token classification, could you explain how thresholding works again? Yes, I can I can show you the code. I'm conscious of the time. We have 10 minutes left, but once I share this data, this code, you'll be able to see specifically like what I'm doing is for each token, I have a prediction for all of the classes. that I'm passing through a softmax function to get probabilities, and then I'm checking like the probabilities for the other class. And if that probability is below threshold, then I'm taking the argmax of probabilities like without the other class. So essentially, like it's this snippet of code, which means that I want to like increase my recall in this way by filtering out the probabilities for other, even if they are like the highest across like all of the classes, but the probability is below a certain threshold, then I want to take the other classes probabilities. So that's the piece of code. And again, that's something that needs to be tested. And if it works well, then maybe it's going to be helpful, but it's also a bit risky because you're kind of like manipulating the model here. It's a bit more prone to overfitting if you use this. Let me check another comment. My F1 is exactly at 961. Should give you a good leaderboard. Let's see. We'll find out. Cool. Let me take a look at the slides. If I want to make sure like we cover the main points from this session. So what we talked about like looking at the data. We used weights and biases tables for this. We talked about deciding on a cross-validation and the local validation approach. We looked at the results of the instrumentation. Specifically, we compared some of our experiments. By the way, this experiment is now finished, so we can go back to our overview and see, yeah, as you can see, like across all of the thresholds, like the results are better for the final F5. And we also can now do a deep dive and understand the like the errors that are made by this better model. Okay, let me go back to the slides. We talked about experiment tracking, looking at the losses, looking at the metrics, organizing your dashboard. As you can see, like I just started logging like all of this data, so I still need to spend a little bit of time making my dashboard like really compelling and like well organized. You've seen how we can do error analysis and compare, like find like the false positives, false negatives, like see where the model is making errors. We can find out the annotation errors potentially in this way. And this gives us like a good ground to have ideas about where we're making errors, how we can fix those errors, how we can come up with a better model architecture or with a better training data. So I'm pretty excited, like this, like having this sort of visibility actually sets you up for success in modeling. One thing which I haven't like really talked much is like this dataset versioning. As you can see, I'm gonna go back to the training script. In my training script, I'm passing the artifacts to the training script in my config, and specifically like I applied a truncation and like a sliding window to the data. I think it's been discussed that it might be a good approach because you want to identify the PII like across like the entire length of an essay, even if it's lengthy. So I've applied sliding window to the data set, and I save this as a weights and biases artifact. And I'm also like using external data. So right now I just added data from Nicholas Broad that was shared. And again, I'm passing this as an artifact. And you can see like with artifacts, I get like specific versions. So when I make some modifications, maybe I apply like the sliding window with a different length, with a different size of the window, then I will like change the version of the artifact here. And when I'm starting the script, I will show you how this is consumed in the script. So I'm using this W&B.use artifact, and then that gives me the directory that downloads the data locally, gives me the link to the directory, and then I can read the training file from that directory. And I do the same for like all of the external data that I'm adding to the script. And if I go now to the dashboard, so let's take a look at the latest one, the one that performed best so far. If we take a look at this specific run, and you can see like, yeah, this F5, maybe I should train it for longer. What do you think? Like if I train it for 5 epochs, will it go to 0.97? I'll see. That's something I will intend to find out. And if we take a look at this overview, you can see that I'm taking as an input this specific data set with my process data. This is the training data with applied stride. And then I'm taking also the external data shared by Nicolas. So all of this now is part of my model lineage, of the experiment lineage. So whenever I go back to experiments and want to compare them, I know exactly what version of my data set I used for this experiment, which I think is helpful if you want to think about like reproducibility and lineage tracking and so on. All right, let me quickly check the questions. Like we're about to end this session. Hopefully this has been useful. Could you share the code? And if so, where can I find it? We will share the code. I will share the link to the code on Discord, like where you're asking the questions. And I will also share it on Kaggle. Let's see if there's any question on Kaggle. Let's see. Let me just refresh this and see if there are any questions. How token classification really works? Yeah, we asked. I think I responded to this already. So I will also share the code like in the discussion section on Kaggle, and we will also share it via Discord. I may need a couple of days just to clean this up. And we'll also send the PowerPoint and recording out via email. Yeah, so you'll also get access to the recording. And we'll share the recording as well on Kaggle, just to make it fair for all of the participants of this competition. Let me wait 1 minute to see if there are any final questions, and then we'll wrap this up. Please feel welcome to join our Weights and Biases Discord at w&b.me/discord. I would also recommend this competition we talked about is an NLP competition. We're already using LLMs to generate synthetic data. Potentially LLMs may be helpful in modeling. We'll find out. And we have like a really good LLM course at Weights and Biases. You can get it through this link, w&b.me/LLM-course. I really recommend it. And then please feel free to connect with me as well on LinkedIn and Twitter. And also, like, I hope to see you on Kaggle. I hope to see you using these pipelines and weights and biases in the way that we shared. If you find some great insights by using weights and biases, please share them on this competition forum or on our Discord. And I wish you good luck modeling and finding out and redacting all of the PII. And also using weights and biases tooling. Thanks, everyone. Have a great rest of your day, and hopefully see you soon.